fuel is something which burns, releasing energy as light and heat. For thousands of years, wood has kept human beings warm. But today, we use many different fuels.
In the 155,000 mark.
How many fuels can you name? And what do we use them for? The energy from burning fuels is used for heating, for cooking food, for powering vehicles. Fuels are also used in power stations to make electricity. But when fuels burn out of control, they can be very dangerous. So, what's the story? When did we first realise that fire could be useful?
The first fires were caused naturally, probably by lightning. But early humans soon saw its potential. Ha! It scared off wild beasts. Back at home, fire kept people warm, and they discovered the tastiness of cooked food.
Uh-oh.
Yummy, 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 yummy. But with no way of starting a new fire, it had to be fed constantly. Fires were guarded day and night to keep them alight. Discovering how to make fire was a major step forward. Fires could be made to order. All sorts of materials became possible fuels, from bones and dried animal dung to oily fish. Coal was found accidentally. Maybe someone set a few sticks ablaze under a ledge of strange black rock, and the rock itself began to burn. Coal isn't the only fuel found in the ground. Gas seeping out of the earth was first spotted thousands of years ago in the Middle East. In ancient Egypt, thick black oil oozing out of hillsides was collected and used as a medicine. But it was also used to make flaming arrowheads. Today, coal, gas and oil fuel the world.
"500 years ago, wood was the most popular fuel. But it was also an important building material. Houses had wooden frames and ships were made of timber. Whole forests disappeared to be replaced by bleak moorland. A shortage of trees meant the search for an alternative fuel was on.
This is a lump of coal, and it came from a mine 140 metres beneath my feet.
Caphouse Colliery in Yorkshire was a working mine until 1985. Now it's the National Coal Mining Museum for England and gives us a glimpse of how coal mining has changed through the centuries.
Are you ready then?
Yeah.
Follow me then.
And the best bit is, we get to go underground. So how far are we going down then?
You're going 450 feet down, 140 metres, 150 yards, just a little bit short of Blackpool Tower. That's how far you're going underground.
When are we stopping?
At the bottom.
200 years ago, coal was the king of fuels, but people had to work in dreadful conditions to bring it to the surface.
150 years ago, just over, your father would be working down mine. Your mum would be working down mine. Your mum would be working it dark for 10 to 12 hours a day, pulling little tubs of coal up and down like that. Your dad's chopping at coal, and you can see him there.
So would it be actually that low?
It's that low because that's height of your coal seam, just short of a metre. So you're on your hands and knees all the day.
So what does this little boy do then? He doesn't look very happy.
He's a trapper. This little lad opens and shuts that door for a bit of ventilation.
So how dark does it get down here then?
Turn your light off, let's show you.
Imagine working in complete darkness with rats scurrying around your feet. And this is what they were mining for: coal, a rock which burns. It's made of ancient plant material and formed 300 million years ago, when most of Britain was covered by huge tropical forests growing on swampy ground. As trees and plants died, they fell into the swamp and became buried in the mud. Starved of oxygen, the vegetation didn't rot. Over many, many years, more mud piled up on top. The trees were squashed together, and heat from inside the earth changed the wood into coal. Today, it lies deep underground, covered by other layers of rock. Here, the coal is sandwiched between layers of mudstone. You can sometimes see fossils of ferns and tiny leaves which have turned into coal. These are the remains of plants which lived long before even the first dinosaurs. By the early part of this century, mining was more mechanised, and women and children were no longer allowed to work down the pits.
Has it always been a dangerous job?
It's always been a dangerous job, mining. Imagine these days working at the side of this machine. That massive wheel's turning round, chopping coal, the noise, the dust, and you've all this problems with mine gases. They could create a massive explosion underground.
Gases trapped in the coal have always caused problems for miners. Methane escapes from the coal and can form an explosive mixture with air. One of the worst mining accidents happened in 1866. 361 men and boys were killed at Oaks Colliery in Yorkshire. But if it's extracted from the coal carefully, that same gas can be useful. First, you need to bake the coal. Heat it up in a small amount of air and it produces a thick yellow cloud. It contains coal tar, which can be condensed and collected, and coal gas, which is flammable. In the past, gas was produced from coal at gasworks in every town and piped to people's homes. But it was expensive and not particularly clean. Coal gas is no longer used, and at the end of the 1990s, the whole coal industry has changed. Only a small number of pits are still open, but they're highly productive and send their coal directly to power stations where it's used to produce electricity. Today, the fuels we use the most are natural gas and oil. North Sea oil was first brought to the surface in 1975. It's made of fossilised marine creatures. Natural gas is found alongside oil. It's almost pure methane, has twice the energy content of coal gas, and is much cleaner. What makes a fuel a good fuel?
A good fuel for me is a fuel that's reliable and will keep this truck on the road through winter and summer.
The ideal fuel for me is one that's safe around the home, especially with these two.
I need a fuel that burns with a very hot flame.
I need a fuel that's light and easy to carry.
For walkers and campers, there's several different fuels to choose from. Each has its good points and its bad points.
This is solid fuel. It's the safest to carry and it's really lightweight. But it burns slowly and it's a bit smoky. It takes a long time to boil a pan of water. This is methylated spirits. It's cheap, it's easy to carry, and it's great in windy conditions because it doesn't blow out. But it's easy to spill, and it's difficult to see the flame burning, so you must be careful. Camping gas burns with a much hotter flame, so it cooks my food much quicker. But gas is expensive, and it's a pressurised can, so you must be careful not to pierce it.
Many different factors are involved in deciding on the best fuel for the job. Not everything can be a fuel because not everything burns. And what appears to be a good fuel for one job may not be appropriate for another.
Sorry.
When fuels burn, they react with oxygen in the air. All fossil fuels contain carbon and hydrogen. To find out what new chemicals are produced, a small piece of coal is set alight and placed under an upside-down funnel. Any products of burning are sucked up the funnel and pass through a series of indicators: cobalt chloride paper, lime water, and universal indicator. As time goes by, they each change. But what do these colour changes mean? The cobalt chloride paper takes on a pink colour. This means water is present. Hydrogen in the coal has combined with oxygen to form water. The lime water goes milky. This means carbon dioxide is produced too. Carbon in the coal has combined with oxygen to form carbon dioxide. Universal indicator turns from green to yellow, showing that the products of burning are also acidic. Acidic gases, like sulfur dioxide, are responsible for acid rain. And scientists are worried that carbon dioxide contributes to global warming. For the environment's sake, we need to choose our fuels carefully. Another major problem of relying on fossil fuels is that resources are limited. In some parts of the world where fossil fuels are already hard to get, they've had to look for alternatives. In India, local coal is of poor quality and imported fossil fuels are too expensive. Wood is in short supply, so they've turned to cow dung as a source of energy. The dung is mixed with water in an underground tank. As it ferments, a gas is produced which can be piped into homes and used for cooking. Or the biogas can be used to power generators which produce electricity. In Brazil, sugarcane has helped to solve their energy problems. About 10 years ago, imported oil became very expensive. Sugarcane grows easily in Brazil's climate and can be fermented to produce alcohol. Alcohol burns easily and is a good alternative to petrol. Here in the UK, some councils are using household rubbish as a fuel. Burning the waste in specially designed incinerators releases energy which can be used to heat homes and offices. As the world's population increases, we need to find alternatives to burning fossil fuels. And in the meantime, we have to conserve what we've got. The RAF search and rescue team have to conserve fuel on a daily basis.
Paul Mac. OK, we've got a job.
They rely on fossil fuels to power their rescue helicopters.
Okay, and it's a fisherman requiring insulin.
60 West.
It's essential to calculate exactly how much fuel is needed.
100 miles, which is £1,000 on the way there.
Yep.
Once we get there, we reckon we're going to be there for about half an hour.
Yep.
Which will be further £500, £1,000 back.
Yep.
And then £500 as a reserve, which gives a total of £3,000, I make it.
Okay, we'll take it up to £3,000, Craig.
The RAF measure the weight of their fuel in pounds. On average, the helicopter uses 1,000 pounds of fuel an hour. Decisions about the amount of fuel and the route they're going to take all have to be made as quickly as possible. The idea is to get the helicopter up in the air within 15 minutes.
OK, we're lifting with 3,000 pounds of fuel, so we've got 3 hours endurance to take us dry.
Once they're up there, they need to use that 3,000 pounds of fuel as carefully as possible. They can't exactly refuel along the way. As they travel to their destination, what factors might affect the amount of fuel they use?
We've got a stronger headwind than was forecast. OK then, en route to the boat we'll stay low and there'll be a lighter headwind. That should save us a few £100 of fuel.
OK, so what height will we approach the boat at?
We'll go out at low level, say about 200 feet.
By flying at a lower height, the wind isn't as strong and they won't use as much fuel. The crew are constantly checking how much fuel they have left.
Down to 2,000 pounds of fuel now, that's 2 hours endurance there.
And we've been airborne around about 55 minutes.
Excellent.
In a way, the helicopter is a bit like our planet. It has a limited amount of fuel on board, which must be looked after. Fossil fuels are non-renewable. Once we've used them, they're gone forever, and we're slowly but surely running out.
Remaining.
1 hour.
How can we all cut down on the amount of fuel we use every day?